In class question 2, there's a number of steps involved. We have a vehicle with a wheelbase of L equals 2.438 metres. Okay, it's driven at the speed of 60 miles per hour, which equals 26.8224 metres per second. Okay, you just apply the conversion factors to show that. Okay, the radius of the corner is 250 metres. Okay, we've got a weight, mass of the vehicle of 1,784 kilograms, and we have a weight distribution front to rear of 4 to 3. So it's front biased, front, rear. Okay, and we've got a table of cornering stiffnesses for different loads, and the question asks, A, slip angles. So we're going to go back through the notes and we're going to look at the equations that we need to work out what the slip angles are going to be. And so if we go back to the slide, we've got alpha F is basically, we've got mv squared upon 2r, because we need to work out that data of table is for one tyre only. Then it's the front mass at the front, so that's the d upon L, and then we divide the whole lot by the cornering stiffness. Okay, so let's work out what's going on. So to work out d upon L, we need to work out what d is. Now obviously, actually what we can do here, d, instead of working out what d and L are, or you've got L, d upon L is going to be equivalent to it's going to be 4 divided by 7, okay, because we've got this front rear distribution of 4 and 3. 4 is on the front, so the mass on the front is going to be greater, so we've got 4 upon 7, we've got v squared, we've got r, we've got L, and C alpha F, we need to work out what the load is on the front. So we've got 4 upon 7 times by the mass, so let's work out what the load is on the front. So load FZF is going to be MF times by G, which is going to be M D upon L times by G. Okay, and obviously the whole lot's divided by 2 because that's per tyre. And so we've got mass 1784 times by 4 upon 7, which is the distribution on the front, times by G, which is 9.81, divided by 2. And so again, if we do the sums, 1784, 4, 7, 9.81, 0.5 times, so we've got 5,000 newtons. Unfortunately, that lines up with the C alpha value in the table, so C alpha must therefore be, according to the table, 1,000 newtons, we've got 1140.2. And so alpha F is going to be 1784 times by v squared, so 26.8224 squared, divided by 2 times the radius, times by d upon L, so that's 4.7, times by 1 over 1140.2. And so again, we go through the calculations. 1784, we've got 26.84 squared, multiply that together, times 250 divided by 4 times 7 divided by, and then we've got 1140.2. So we've got 1.286 degrees. 1.286 degrees. So there's our first value. Repeat the process for alpha R, but for alpha R, the issue we've got as you'll see, so it's mv squared upon 2r c upon L, that's the difference, 1 over c alpha r, okay? And c upon L in this case is 3 upon 7. Now the issue is, again, we go through the process to find the loading, so it's going to be mrg upon 2, because there's 2 tyres, so that's going to be mc upon L times by g times by 1/2. Okay, and so this is going to be 1784 times by 3 upon 7 times by 9.81, that's our g, times by 1/2. And this comes out to be, can do the calculations, 1784, 9.81 is our g, we've got 3, 7, and then 2, so we've got 3,750 newtons. 3,750 newtons. Now the problem we've got here, as I mentioned, is that that value doesn't lie on our table, so we need to do some interpolation. Okay, so the interpolation, we've got, if we draw a little graph, it helps. We've got 3,000 here, and we've got 4,000 here. So this is our FZ, and up this way we've got RC alpha. So we've got, at this point, we've got 760, so that's there, and for 4,000 we have 1,000. Okay, so that's this point up here, and we're assuming this is a straight line, okay, and what we need to find is the value at 3,750, so what is this value here? So if I call that, well, let's call that C alpha R, for the sake of argument. We know that we've got some common triangles here. Okay, 2 right angled triangles. We've got one, if I colour it in, let's go for red. We've got one right angled triangle here. Okay, and then if I do a blue one, we've got one right angled triangle here. Okay, they're common triangles, so what we can do is we can do interpolation. We can say that 4,000 minus 3,000. So let's go for the height over the base. So that's going to be this 1,000 minus 760. That's going to be equal to 3,750 minus 4,000, and then we've got up here C alpha R minus 760. And obviously that equation could be rearranged. C alpha R equals, we've got 3,750 minus 4,000, this is minus 3,000, sorry. Times by 1,000 minus 760 divided by 4,000 minus 3,000 plus 760. If you do that sum, that comes out to be 940 newtons per degree. So that's our C alpha R. So the slip angle at the back is going to be, this equation up here, 1784, 26.8224 squared divided by 2 times the radius times by C upon L, so that's 3 upon 7 times by 1 over 940. If you do that sum, 1784, 26.8224 squared times 215 divided by 2 divided by, then we've got 3 times 7 divided by, then we've got 940, right, so 1.170 degrees. 1.170 degrees, and that is the rear tyres slip angle. Part B asks to calculate the lateral acceleration. Well, that's quite straightforward. AY equals v squared upon r. V we know is 26.8224 squared over r, which is 250. So again, calculations for that, 26.8224, 250, we have 2.8778 meters per second squared. Part C says find the steering angle, okay, or delta equals 180 over pi times f upon r plus alpha f minus alpha r. So 180 over pi times by 2.438, which I believe is immediately, this is the wheelbase, over 250, which is the radius of the turn, plus 1.286 minus 1.170. So that's using alpha f and alpha r that we found earlier. And again, doing those sums, so 2.438 divided by 250, and we've got 1.286, 1.170, and 0.675. 0.675 degrees as a steering angle. For part D, it says find the understeer gradient, so that's Ku. And again, we'll use the equation that's in the notes. So if we go to that particular slide, we put m over 2l d upon c alpha f minus c upon c alpha r. Now in this case we actually need to find c and d as values of distance, and so let's do that. So we know the wheelbase L is 2.438 meters, and we know that c upon L is 3 upon 7. Okay, so c is 3 upon 7 times by L. So C is going to be 3, 7 divided by 2.438 times, so 1.045 meters, and D, you can either do 4 over 7 times by L, or obviously subtract 1.045 from L, so we've got 2.438 times by 4 divided by 7, 1.393, 1.393 meters. The understeer gradient, we've got the mass, which is 1784, divided by 2 times the wheelbase, 2.438, times by D, which is 1.393, divided by C alpha F, which we calculated to be, where do we find it, 1140, 1140.2, minus C over 940. So if we do that sum, 1784 divided by 250, no, sorry, 1784 divided by 2, so 2.438, okay, and then we've got 1.393 divided by 1140.2, and then we've got 1.045 divided by 940, subtract those from each other, multiply that by that, we get Ku is 0.0403 and the units is degrees per meters per second squared. Okay, so that's the KU. And then E says what is the, I believe is what is the characteristic, well, since alpha F is greater than alpha R, that means that we've got an understeering vehicle. And F says find the characteristic speed, so V characteristic, square root of 57.3 times L over KU. So we've got 57.3 times 57.3 2.438 divided by 0.0403. And so if we do that sum, 180 divided by pi times by 2.438 divided by, so if I swap that round, we divided by, and then we take the square root, 58.9 meters per second. Which is quite fast. We convert that from velocity to speed, meter per second, happens to be 131 miles per hour, so approximately 131 miles per hour. So that's the solution, okay? So we found part A, it's quite long, to find the slip angles, okay? So if I mark the part slip angles, okay? And then we've part B was to find the natural frequency, which is, sorry, the lateral acceleration, and part D was to find the steer angle, which was 0.675. Part D was to find the understeer gradient, and part E was to work out the characteristic, so it's understeering, okay, and then we also had to find the the characteristic speed, which was 131 miles an hour, or 58.9 meters per second.